Next, we want to look at indefinite and indefinite integral, and we are going to consider this curve, the curve shown here. We are going to consider this area bounded by line x is equal to a and the line x is equal to b. So there are two ways of estimating this area under the curve. One of the ways is whereby we subdivide this area into equal rectangle. In this case, in this case now, in this case, we subdivide this region into equal number of rectangles. In this case, as you can see here now, our area will be underestimated because there is a section which is being left here. There is a section which is being left here. If you consider this area here, we say this is figure 1, and this is figure 2. In figure 1, in figure 2, you can see there is a region being left here. So this is underestimation. Now, another way is dividing it into these equal rectangles as shown here. And when you consider this figure 3, when you consider our figure 3 here, this is over. We are overestimating here. This is overestimation. Because if you consider this figure here, this area is more than the area here. The shaded area here is more than this area. And in this case, the shaded area is less than the required area. This is less underestimated. This is more overestimated. Now, to overcome that, what we can do, it is to subdivide this region into smaller rectangles, as many as possible, such that the height of those rectangles can be assumed to be equal to y. And now we take the small change. We take that now our width of this rectangle is delta x here. Now, the area of a rectangle is length which is y times width. So the area of each strip is length times width. What we are calling strip here, it is the rectangles which we subdivide our region. We subdivide our region into number of rectangles. So each of the strip will have this area. It will have the area given by y is equal to delta x as shown here. Now, the area between x is equal to a and x is equal to b as shown here. X is equal to a at this point here. Our x here is a and there it is b, or even as shown here. X is equal to a and x is equal to b. Now, the area now it is the sum. We add all these rectangles and we use the symbol for addition. We add this sum symbol here means summation. So we are adding from x is equal to a all the way to x is equal to b of these equal rectangles which we have subdivided our region into. This region, equal rectangles, as shown here. So when we do that, when we sum now, we take the limit as the width of this rectangle becomes smaller and smaller as it tends to 0, written this way. As delta tends to 0, the summation will be equal to the integration from a to b of y with respect to dx. Y is the curve given. Now, in this case, a is referred to as the lower limit and b is referred to as the upper limit. Now, so in case you are given the boundaries, these are the boundaries. This is what is called the boundary. In case you are given the boundary of your curve, Like in this case, that is what is called definite integral. And it is written this way. For example, a to b of y with respect to. This symbol means we integrate function y with respect to dx from a to b. In this case, this is called definite integral. In the case now you are not given the boundaries, that is what is referred to as indefinite integral. Indefinite integral. So you have this example here. We have to evaluate this from 2 to 6. Bracket 2x squared plus 3 with respect to dx. So to do that, first of all, integrate. How do we integrate? We integrate by adding the index with 1. So here we are going to have 2 plus 1, which is equal to 3, and we divide. So that is why here we have 2 over 3 x power cubic. Here it is x power 0 plus 1, which is equal simply 3x plus c. So integrate this with respect to x. We integrate that with respect to x. That is the first step. Then the second step is that we place the integral in a square bracket and insert the limit. So our limit is 2 to 6, as we have done here, 2 to 6. Then the step number 3, first step, integrate. Second step, place the boundaries and the bracket, square bracket as shown here. The third step which we are going to have is we substitute. We substitute x is equal to 6 and x is equal to 2 here. So where you have x, you write 6. So you have 2 over 3 s cubic plus 3, 6 plus c. When you simplify, you are going to get, this is 118 divided by 3 times 2. I mean 186. That is 6 times that. That is 6 times 3 is 196 divided by 3 times 2. You are going to plus 18. You are going to get 162. The other part, it is substituting x is equal to 2 there. Where you have x, you write 2 there. So 2 over 3 s cubic plus 3 times 2 plus c. You simplify and you are going to get that 4 over 3 plus c. Then from there, what you do now, you subtract the result of lower limit from that of the upper limit. In the other ones, we say 162 plus c minus 34 over 3 plus c. Of course, here, c minus c will cancel and we will be left with the 162 minus 34 over 3 to give us 352 over 3, which is the same as this is an improper fraction, which can be written as proper fraction as 152 over 3, as shown there. Now, these steps can be summarized as shown. So instead of following all this, instead of following this long procedure, integrating, placing the bracket, substituting, subtracting the result of the lower limit from the upper limit, we can do it here in a summarized form as I have shown you. So first of all, you integrate this cap. How do you integrate? Always add the index 1 and you divide by the result. So you have 2 over 3 s cubic plus 3x plus c. Then you insert the lower limit and the upper limit in square bracket as shown. You substitute as shown there, and then you simplify as done here. So you simplify 162 minus 34 over 3, which is equal to 152 over 3. So that is how you use integration to solve an equation like the one shown here to get the value. So first of all, you integrate, substitute the boundaries, you substitute them, you integrate, then you insert the upper and the lower boundary on the square bracket as shown. You simplify and you get your result in a simple method as done there for you.